Hello everyone. So we were studying about hypothesis testing, and in the previous classes we did studied ANOVA and chi-square test. Okay, I want to discuss more about hypothesis testing. So we should have a recall related to it. Okay, so hypothesis testing and t-test in machine learning. The concept what we have learned about hypothesis testing is hypothesis is a statement which we give considering a sample of data, and we do perform the test over this sample so that to prove that it is applicable for entire population also. Okay, because we can't take the entire population data. We do work for sample only. Okay, fine. So that's what happens in hypothesis testing. And according to the definition, also, hypothesis testing aims to draw inferences about the population. So we are having sample, we do apply all the test over the sample. Okay, and this is for your population. Okay, ultimately we have to draw the inferences over the population. In machine learning, there is t-test also that is commonly used to draw the inferences across the models, and we apply this kind of test only, like ANOVA, chi-square. Echo. Okay, so like this only now we have done in the previous lectures. Okay, so you are available with the sample of the data. Okay, this is the sample of the data. We do apply the test, and it will be applicable for the entire population. That's what it means. Okay, and in hypothesis, you very well know about null hypothesis, alternate hypothesis. Okay, so null hypothesis is a basic statement that is our assumption. Okay, we do assume something. Okay, initially we do assume something that is called as a null hypothesis. Okay, an alternative hypothesis is the hypothesis or the statement which is applicable only when the null hypothesis is false. Okay, then only alternate is followed up. All right, and the statement for null hypothesis is in case of ANOVA, we have studied that the mean is same for all the samples. That's what we have written as a null hypothesis in ANOVA. In case of chi-square, we told that there is a difference. Okay, there is a difference in the distribution between the two samples. Okay, that's what we told in the chi-square. Okay, so we have to define the null hypothesis initially. We have to do the calculations. We have to find certain values. We have to compare with the critical, and then we do conclude our results. Okay, there is a p-value or the probability value. Okay, so it represents the evidence or a significance level for the null hypothesis in machine learning. Okay, and typically it is set to 5%. So we have seen the value of p, that is like 0.05, that is significant level. Okay, so 95% is the confidence level. That means whatever we are saying in the hypothesis is likely to be true. That means it may fall in the region of 95%. Okay, however, if it is doesn't fall in this region of 95%, obviously it will go into the significant level. Okay, so we do perform like this: p is less than equal to 0.05. Most of the cases we have taken significant as 5% only. Okay, fine. So if the value of p is less than this, so we are going to reject the null hypothesis. Else we are going to accept the null hypothesis. That's what we are going to do. Okay, and we do collect the sample of the data. We do perform the testing, and then we finalize whether the hypothesis is going to be accepted or rejected. That's what the steps of hypothesis testing. Okay. Um, T static. Okay, calculating the T static. That means test. For example, testing a shipping container company's claim of each container weighing 1000 kg. Okay, so this is the formula for T static. Mean minus claim divided by standard deviation under root of sample size. This is the formula for T static or a T value. Okay, and then we'll be having a T table. From there, we'll compare with the critical value whether this is greater than or smaller than. So there we do perform the comparison. Okay, so this is T static. Okay, fine. So ये जो है आपको, this is the statement given to you. Testing a shipping container company claim of each container weighing 1000 kg. That means each container is of 1000 kg. Okay, let's prove this thing that each container is of having 1000 kg or not. Okay, fine. So T static, and this is the formula: mean minus claim divided by standard deviation. Uh, okay, and divided by root of sample size. This is T static formula. Okay, during hypothesis testing also we may face errors. Okay, there could be an error. We can uh, do a mistake. That is a possibility. Okay, fine. So what we understood so far is you are having a population of data. You are having a population. You do collect a sample. You apply techniques over this sample. It depends what kind of problem statement is. For ANOVA, we are having a numerical data that is continuous in nature. For chi-square, we are having a categorical data. So accordingly, you have to decide that which technique you need to apply. Okay, after application, we are having some reference table. We do compare the value with the reference table. Okay, that is a significant value, p value, 5%, less than 5%, greater than 5%. Okay, whatsoever. And then will we say that, okay, null hypothesis is correct or accepted or not accepted. That's what we decide. However, in this process also, we can make a mistake. हो सकती है. ठीक है. We may reject a null hypothesis even though it is true. So this is type 1 error. And we may accept the null hypothesis when it is false. This is type 2 error. हो सकती है गलतियां. Mistakes are possible. ठीक है. It happens na in calculation and or in interpretation or considering the wrong or faulty entries or the values. Okay, so this can be possible. Okay, so we can have two types of error: type 1 error and the type 2 error. Okay, fine. So due to working with sample data instead of the entire population, there could be possibility, क्योंकि सैंपल बदलते रहते हैं, जरूरी थोड़ी ना है कि जो सैंपल का ओपिनियन है वही पॉपुलेशन का होगा. Okay, it's not mandatory because sample is a small size data, a small size, and according to this sample only you are deciding something. There could be changes, possible changes can be there. Okay, तो हो सकता है गलती हो जाए. There could be chance of mistake. Okay, there are certain other approaches also, like creating models with different set of features for hypothesis testing. Consider feature interdependency. In regression problem, we follow p-value, iteratively improve the model. Different approaches, different algorithm, different tests. It depend करता है आपकी क्या problem statement है, क्या करना चाह रहे हो, what you want to do. Okay, fine. So hypothesis testing, it's important in machine learning. That helps to validate the assumption. We do have assumption. That's what we call as a null hypothesis. Okay, and we need to draw the meaningful inferences for model improvement. Okay, so in questions, in research, you may be asked to prove, you may be asked to validate your result. बोला जा सकता है, पूछा जा सकता है, जाता है. Okay, in your research papers, in your research publication, you may be asked to prove, you may be asked to validate your result. There you have to apply hypothesis testing. Okay, so we have to carefully consider the results, we have to carefully consider the errors, we have to look out for the alternative approaches so that we should not be having any error. So data science project starts with exploring and analyzing the data. That's what we do. First we get the data, we understand the data, We check each and every feature. What is the meaning of the feature? What is the value present in the data? We do the analysis. We explore. And hypothesis testing is crucial for confirming the observations about the population using the sample data. So we are having a sample data. Okay, we have been given a sample data. Okay, and we do all model training and everything over that sample of data. Okay, we get the results from that sample of the data. But anyhow, you have to perform the hypothesis testing, whether whatever be the results you have obtained, whether whatever be the model you have prepared, and the results which you are getting, that is applicable to the entire population. वो सबको फॉलो कर रहा है कि नहीं कर रहा था, entire population is satisfied with your results or not. It may happen that okay, you are available with some set of data, you applied all the techniques for the set of data, you got the results also, and you have generalized the solution for that कि whatever I did is ना 100% करेक्ट, तो ये पॉसिबल नहीं है. ओके, मिस्टेक हो सकती है, वो 5% का जो कंसिडरेशन है. ठीक है, आप ऐसा, देर इज अ पॉसिबिलिटी कि आपने बोल दिया नल हाइपोथेसिस ट्रू बट इट मे बी फॉल्स, और यू हैव क्लेम दैट इट इज फॉल्स, इट मे बी ट्रू, कुछ भी हो सकता है. ओके, तो टेस्टिंग हम लगाते हैं, तो वी हैव टू वैलिडेट अवर अजम्पशंस. ओके, अबाउट द पॉपुलेशन. फाइन. So we do formulate our hypothesis, we do consider null hypothesis, alternate hypothesis, 5% adjustment, ये सब करते हैं अपन, और टेस्ट लगाते हैं. ठीक है, वी डू कैलकुलेट द पी वैल्यूज और द प्रोबेबिलिटी वैल्यू, ये करते हैं, 5% का रख देते हैं, 5% का रख देते हैं. देन देर इज अ फॉर्मूला फॉर कैलकुलेटिंग द पी वैल्यू. इन केस ऑफ अनोवा ऑल्सो यू हैव टेकन सम रेशियो. ओके, इन अनोवा ऑल्सो यू टुक द रेशियो, वो एसेस करके लिया था आपने रेशियो. ओके, सो you do calculate the value and then compare with the critical value. Okay, take the significance, that's what you have to do. So this is how we do perform the steps. Okay, read and understand the data, build your machine learning model, formulate and test the hypothesis. Okay, and based upon the outcome refine the model. If you are having any difficulty, that means according to the test which you have performed, according to the hypothesis given and the test you have performed based upon the hypothesis, okay, what kind of results you are getting, what kind of outcome you are getting, so kindly understand that thing, and then refine your model if there is some mistake. Okay, fine. All right, तो ये है फिर. ठीक है, and there are different types of hypothesis testing. For example, z static, when the sample is normal distribution. Okay, we do use z static, z statistic. Okay, it compares the sample mean with the population mean. So sample mean and the population mean comparison, this is what happens in z static. In t test, we do consider a sample which follow the t distribution. So t distribution means student t distribution. Okay, you very well know that looks like normal, but actually थोड़ा सा difference है. That looks like normal. Okay, but this is student t distribution. So when you are having a small sample of data, and I already told that in small sample of data, you are more likely to be have a distribution is a student t distribution, which is having thick tails. वो कुछ ऐसा होता है, student t. Okay, and normal distribution look like this. This is normal distribution. Okay, so with the sample, you do apply t distribution only. Okay, fine. So in this particular case, t static is used. Okay, f statistic is used when we are having samples, three or more groups. So we have used f static in ANOVA, if you remember. We have used this only. We in the data set which I taught you was having three groups of students, G1, G2, G3, and we talked about the books they study. Okay, we were having three groups and three students, and the mean of the groups they study. Okay, these groups, we are having three students group, and how many books they study, we do calculated the mean, and we checked. In hypothesis, we told that in ANOVA, the null hypothesis, we told that the mean is same. Okay, that is the null hypothesis, and the alternate hypothesis was the mean was different. Okay, so there we have considered F static. So when you are having different samples, two or more group, then F static is considered. If you are having a single samples, okay, one sample or two sample, then you can apply T static. Else you can apply Z static. Okay, that's what you can do. Okay, fine. All right. Okay, then chi square also we have studied. Okay, chi square test. Okay, here we use categorical values. We apply independence and goodness of fit test. Okay, test for independence and goodness of it. Okay, so here if we do have a categorical values x1 and the x2, these two are independent of each other. That's what we have told in the null hypothesis. I think in null hypothesis we told that they are not independent. In alternate they are independent. That's what we have told in chi square. Okay, and the problem statement which we have done in the previous class was based upon male and female and their political opinion. Okay, to which political party they are supporting. So in that regards, now we have done chi square. So chi square give you the test for independence and the goodness of it. Okay, so these are certainly used hypothesis testing. So major we have studied, that is ANOVA also I taught, chi square also I taught. Okay, only the part is implementation that we'll see ahead. Okay, that we'll see ahead. How to use this techniques. Okay, type 1 error, type 2 error also I told you. What is type 1 error? That means rejecting null hypothesis when it is true. That is type 1. Accepting null hypothesis when it is false is type 2 error. Okay, fine. So this is how we can draw table for it. Just like a confusion matrix. Okay, so null hypothesis is true, null hypothesis is false. Reject the null hypothesis and accept the null hypothesis. So we reject the null hypothesis when it is true. This is type 1 error. Okay, we rejected the null hypothesis even though it is true. This is type 1 error. And we reject the null hypothesis when it is false. This is correct decision. No worries. Okay, now we fail to reject the null hypothesis if it is true. Then this is a correct decision. That means we are accepting the null hypothesis. And here, here we fail to reject the null hypothesis. That means we accepted the null hypothesis even though it is false. So this is type 2 error. तो confusion है ये. Okay, fine. ये बना रखा है यहाँ पर वो टाइप 1 और टाइप 2 एरर के बारे में. ऑल राइट, फाइन. सो ये बात है नॉर्मल डिस्ट्रीब्यूशन. ओके, अगेन वेरी इंपॉर्टेंट कर्व, नॉर्मल डिस्ट्रीब्यूशन. So the basis of hypothesis depends in the normalization only and standard normalization. All the hypotheses revolve around the basic two these terms, how the distribution of the data is. Okay, and this is the normal distribution plot. Okay, so on y-axis I am having the probability, and on x-axis you can see the distribution of the data. Okay, so is 68%. This is 95.4%, and this is 99% of the data. 1 sigma, 2 sigma, 3 sigma. I hope if you remember. 1 sigma, 2 sigma, and 3 sigma. Okay, fine. So that's what I taught you. बता चुका हूं मैं पहले. Okay. So in the first case, you can see that there is a normal curve. All the normal curves have the same mean and the variance. In the second, you can notice that there is a difference. Okay, so I am having right now one curve only. I don't. Okay, ये वाला है. These three curves. Okay, ये these three curves. Red, blue, and the green. इसके बारे में बोल रहा है. It's talking about these three. Okay, fine. So we are having three curves, and these three curves, it's comparing with respect to the normal distribution. Normal distribution is very much important in performing the interpretation, क्योंकि the normal distribution is the reference curve for us. ठीक है, तो उसी को कंसिडर करते हैं अपन. एंड वी डू चेक कि मीन क्या है, स्टैंडर्ड डेविएशन क्या है, व्हाट दे आर. ओके, सो we are having, okay, four curves: blue also, green also, red also, and yellow also. Okay, we can see that this green one is oriented left oriented. Okay, blue is having so much Okay, a very long tail. Okay, however, the peak is very okay. If we check, it is having a very high peak. Okay, and yellow one is like flatness in case of yellow one, and I think red is red. This red one is normal. Okay, so there can be like a different kind of distribution, and it is saying ki okay, I am having like a mean zero for the three of the plot. I am having mean zero, one I am having mean minus two, and ये variance है. Okay, variance for the red one is 1, variance for yellow is 5, variance for green is 0.5, variance for blue is 0.2. Okay, so I am having different mean and the different variances for the plots. Okay, so that's what we are having, and this is your normal distribution. A variable is said to be normally distributed if the distribution has a shape of normal curve or a bell shape. Okay, or it is having symmetry. That is what a normal distribution, where mean, median, mode all are equal. Okay, and the formula for the normal distribution. Okay, that's what they said. Okay, simple. Okay, x new, that means new value of x, that is calculated as x minus x mean upon x plus minus x mean. This is a standardization formula. Okay, however, the formula for normal distribution I have written many times, under root of 2 pi sigma e की power minus x minus nu का whole square upon 2 sigma square. This is the formula for normal distribution, and this is for standardization, standard scalar. Okay, fine. This is standardized normal distribution. Okay, where mean is 0, standard deviation is 1. This is how we are going to calculate the new value, x new. Okay, fine. So that's about normal distribution. Okay. Null hypothesis, alternate hypothesis, I've already told you. Okay. So this is type 1, type 2 error. There are few things also mentioned. Okay. So, all right, let's study them also. Okay. Hmm. So, null hypothesis, general statement. Okay, null hypothesis, general statement. It is a basic assumption. Okay, for example, a company production is 50 unit per day. This is a statement, general assumption. Okay, alternate means it's contradictory of null. No, a company production is not 50 unit per day. That is alternate hypothesis. Okay, here is the example. A company production is not 50 unit per day. This is alternate hypothesis. Okay, fine. And then we are having level of significance. That means refers to the degree of significance in which we accept or reject the null hypothesis. 100% accuracy is not possible. We never say that whatever we do collected a sample and whatever be the conclusion we can draw over the sample is 100% accurate. No. Okay, that is not possible. So we do have some significance value. Okay, and in that regards 5% is the reference, so 95% we can be confident. However, 5% there is a chance of mistake, that is called as a significance value. And if you do a mistake, type 1 error, type 2 error, that I have already taught you about. Okay, type 1 error means in hypothesis testing a normal curve shows that a critical region is called as alpha region. Okay, you very well know about the alpha region. This region is alpha region. 5% significance. Okay, so in type 1 error, we reject the null hypothesis. That means we are saying that it is coming in a significance level. We are rejecting the null hypothesis. Even though it is true, but we are rejecting it. Mistake it. Okay. And in type 2 error, we are accepting the null hypothesis even though it is false. That means we are putting it into a confidence level. but it should be present in a significance level. That means we are putting it into a beta region, but it should be in an alpha region. So this is type 2 error. So you may be asked a question, what is type 1 error, what is type 2 error? In statistics, in Viva, you may be asked the question, what is type 1 and what is type 2? You have to tell. Okay, you have to tell like this. Okay, sir, fine. How you are going to tell about it? Let me share my entire screen. Okay, and go slow. Fine. No need to think like hard and fast or tough or complicated. Go slow. Okay, what you have to tell? You have to tell that, listen, we do have, we do follow normal distribution of the data. That's what you tell. Normal distribution, I already taught you. What do you mean by normal distribution? So tell them, okay, we do follow normal distribution, and this is how it looks. Okay. Now, you are asking about hypothesis testing. Tell them, hypothesis statement. Testing, I need to validate that the statement given is correct or not. To whom the statement is given, or whom you are going to give the statement. You say that, okay, we do collect a sample, we do apply the test over the sample, and this is to validate that whatever in hypothesis we are seeing, that is applicable to the entire population. That's the reason we are doing the hypothesis testing. Okay, then you have to tell that um, it's not mandatory that whatever we have said over the sample is 100% correct. बिल्कुल भी जरूरी नहीं है. It's not mandatory that whatever you have said over the sample is 100% correct, that it is followed by the population also, because there may be different collection of samples in the entire population. You may collect this sample, 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 any kind of sample you may have collected. और ये भी random है. This is random sampling, so it's not mandatory na, that you are 100% correct. There could be a chance of doing a mistake. Okay, so let it be. You say that, okay, we are 95% confident. इतना तो आपको होना ही पड़ेगा. At least you have to be 95% confident. See why? Why 95% confident? See, you are having a data. You applied all techniques over the data. You have prepared your model, machine learning model. You trained your model over the data. सब कुछ कर लिया तुमने भाई, सब कुछ कर लिया. डेटा है, you use this data, you performed all the analysis, you did all the interpretation, you trained your model. Now your model is ready to give results. अब आपसे कोई पूछे कि भाई ये सही है कि नहीं है, तुम्हें 95% कॉन्फिडेंट तो होना ही पड़ेगा. If someone asks you that whatever you have done so far, whether it is correct or not, so you have to be 95% confident. If you say that no, I'm not confident, whatever I did is okay, it's giving the result, but I'm not confident, so how you are going to validate your result? That is a question. आपने जो रिसर्च करी, आपने जो रिजल्ट्स निकाले, whatever you did, and if you are not 95% confident also, then obviously your theory will be rejected. आपके रिजल्ट्स को रिजेक्ट कर दिया जाएगा. वो बोलेगा भाई तू खुद ही कॉन्फिडेंट नहीं है, तो तू कई के लिए कर रहा है, फिर ये क्या मतलब है करने से? इफ यू आर नॉट कॉन्फिडेंट तो फिर क्या मतलब है, रिजेक्ट वैसे ही हो जाएगा. सो यू हैव टू बी लाइक 95% कॉन्फिडेंट. हाँ, 5% यू कैन से दैट ओके वॉट एवर आई डिड, देर इज अ चांस that 5% of my theory can be रिजेक्शन हो सकता है. 5% का चांस है, बाकी 95% आई एम कॉन्फिडेंट that whatever be the results I have got, that is applicable to the entire population. Okay. अब उसमें भी ये मिस्टेक हो रही है, टाइप 1 और टाइप 2. टाइप 1 एंड टाइप 2. टाइप 1 में क्या हो रहा है, रिजेक्ट कर रहे हैं इवन दो नल हाइपोथेसिस इज करेक्ट. टाइप 2 में क्या हो रहा है, एक्सेप्ट कर रहे हैं इवन दो द नल हाइपोथेसिस इज इनकरेक्ट. So we are having two regions. Okay, in normal distribution, we are having two region. One is alpha region, one is beta region. Beta region is confident region. You may be asked, what is alpha and beta? So beta region is a confidence level, 95% region. Alpha is a significance level, 5%. Okay, so there might be mistake. हो सकता है. Okay, that's what it is saying. Okay, fine. Now, one tail test. A test of a statistical hypothesis when the region of rejection is only on the one side. Okay, so when you are having either on this side or either on this side, this is one tail test. Okay, this is one tail test. That means a college has more than 4,000 students, or data science is less than 80%. That means those who adopted data science, that is less than 80%. Okay, so this is one tail test. All right, fine. We can have two tail test also. So in two tail test, it is a statistical test in which critical area of distribution is on the two side. That means here also and here also. Okay, here also and here also. This is two tail test. Okay, so यहाँ पर आपके critical regions हैं. Okay, these are the critical region in two tail. In one tail, either I am having on this side or either I am having on this side. Okay, ये चीज है. So one tail or two tails. So for example, college we don't have 4,000 student, or data scientist not having 80%. Okay, 80% of the student has not adopted data science as a subject. Okay, so if the sample being tested falls into either of the critical area, the alternative hypothesis is accepted instead of null hypothesis. So we may have a critical region on either of the side or on both the sides. That is also possible. हो सकता है critical region. Okay, पूरे पूरे पर chances हैं. It's not like that you are having a critical region at one side only. No, you may have on both the sides also critical region. Okay, that's what they have made two tail. Depend upon the condition. Okay, depends upon the condition. You may have a critical regions on either of the sides or either on both the sides. Okay, fine. So remember this thing, very important. Okay, so that's one tail and the two tail test. Okay, p value, that is a probability value I told you. Okay, it is a probability of finding the observed or more extreme results when the null hypothesis of the study is under a question. That is true or not. So if the p value is less than the significance, p value is the probability value. So we do calculate the probability. Okay, and we, for calculating the probability, we take a ratio of certain terms. Okay, that's what you did. You took the ratio of certain terms according to the formulation which we are applying in ANOVA or in chi square, whatever we are doing. So we do take the ratio of the terms and then we compare with the critical value. Okay, or we do compare with the significance actually right now. That's what we say. P value is compared with the significance. P is less than equal to 0.05. That's how we compare. It is greater than 0.05, that means we are in a confidence level. It is less than 0.05, that means we are in a significant level. Okay, fine. So, for example, you have a coin and you don't know whether it is fair or tricky. So let's decide null and alternate hypothesis. Null hypothesis means coin is fair. Alternate hypothesis means coin is tricky or biased. And alpha, or the significance value, is 0.5%. Now toss the coin and calculate the value of probability. Toss the coin. You toss the coin, you got head. You again toss the coin, you got head. You again toss the coin, you got head. So in three tossings, you got head, head, and head. Okay, that means mostly head is coming. That means the coin is biased. Okay, mostly it is head is coming. However, we always say that the result should not be biased. It should be like 50-50%. Okay, fine. So that should be something which we have to consider. All right, fine. So we toss the coin for the first time. For example, result is tail. So probability value is 50%. Okay. Now if we toss second time, the result is tail. Now the probability value is 50 by 2, 25%. If you toss the coin six times, the probability value is 1.5%. That means by again divide and divide and divide. And if we set the significance level as like confidence level is 95% and 5% rate of error, then our null hypothesis does not hold good. We need to reject and propose that this coin is tricky. Okay, so the probability of getting head and tail is 50%. One time you got tail, another time if you got head, so probability is maintained 50%. But when you toss the coin, you got tail, for example. Another time you toss, you again got tail. Another time you toss again, you got tail. So the probability is 50% initially. But for the two times or three times, if it is coming, so divide it by the number how many times you are getting. Okay, so in that particular case, your probability gets down, down, down. Okay, and the significance level what you have considered is 5%. So if it get reduced by that much, less than 5%, then obviously your coin is tricky or unfair. Okay, so this is how we do perform the testing. Okay, fine. Now t-test. T-test, I already told you that if you are having a sample of the data, okay, we do apply the t-test over it. Okay, and it is an inferential test which we use to determine if there is a significance difference between the mean of two groups. Okay, so in general, we do take the two groups. Okay, so it is mostly used when the data set of record as the outcome by flipping of a coin 100 times would follow normal distribution and may have unknown variance. So it's just a statement mentioned. Okay, just a statement mentioned related to it. If we are having two groups, we are going to find the difference between the mean of the two groups. Mean. Okay, mean of two groups. Okay, so this t-test is applied to see whether the mean of the two groups are same or not. In t-test also we are having one sample test and two sample test. Okay, in one sample test we do consider a sample mean and we do take the population mean. So one sample में you are having only a sample, तो कंपेयर तो करना पड़ेगा आपको किसी ना किसी से. Okay, so here we do take the sample mean and we do take the population mean. However, if you are having two samples, तो उन दोनों के बीच में टेस्ट कर लो. सैंपल वन और सैंपल टू के बीच में कर लो, तो वो टू सैंपल टेस्ट हो जाएगा. If you are having one sample, then compare the sample mean with the population mean. But if you are having two samples, then compare the mean of the two samples. That is t test. और क्योंकि वो सैंपल है, वो छोटा है, तभी टी टेस्ट है. क्योंकि इट विल लुक लाइक स्टूडेंट टी डिस्ट्रीब्यूशन, और नॉर्मल नहीं होगा. इट डजंट लुक्स लाइक नॉर्मल. वो स्टूडेंट टी डिस्ट्रीब्यूशन की तरह दिख रहा होगा. ओके फाइन. सो जैसे कि वन सैंपल टेस्ट में वी आर हैविंग 10 ages and we are checking the average age is 30 or not. This is the question. We are having 10 ages. Okay, and we have to calculate the average, whether it is equal to 30 or not. That is one sample test. Okay, in two sample test, we are looking forward for the association between the two sample data, sample 1 and sample 2. Sample 1 and sample 2. That's what we are going to see. Okay, होगा mean ही. You'll take the mean of sample 1, you'll take the mean of sample 2, and check whether the mean are equal or not. This is happens in two sample test. Okay, fine. We are having paired also, paired sample test. Okay, that means the paired sample t test is a dependent sample t test. Okay, and for example, if we were to collect a blood pressure of an individual before and after treatment, that I have already explained you. ये मिक्स्ड भी था ना, मिक्स्ड भी तो था, ये मिक्स्ड ही है, पेयर्ड मीन्स मिक्स्ड, मिक्स्ड टेस्ट है. Okay, so we do collect the blood pressure. Okay, at different time interval. So this is mixed or paired sample test. Okay, so here we can give the hypothesis like mean difference between two sample is zero, and the mean difference between two sample is not zero. Okay, zero and not zero. That's how we can define. ये भी कर सकते हैं. All right, fine. तो ये चीज भी है हमारे पास. We can run a Z test also. Okay, so several different test types of tests are there in statistic. F test, chi square test, ANOVA test, T test, Z test, and different tests. Okay, your sample size is greater than 30, then use Z test, else you are going to use the T test. Okay, if the sample size is less than 30, then use T test, else use Z test. Okay, fine. So data points should be independent of each other. In other words, one data point isn't related to another data point. The data should be normally distributed and the sample size should be over 30. Okay, this doesn't always matter, but in general, we say that 30 data points should have to be there. Okay, so the Z test, when your sample size is greater than 30, apply Z test, else T test is applied. And the only thing is you have to check the mean, whether the mean of the samples are same or not. That's what you have to check. Ye test. Okay, just check the mean. And the distribution should have to be normal. Okay, for the sample, if it is less than 30, then it should be T distribution. If it is more than the 30, then it should be normal distribution. ऐसा बोल रहा है वो. And keep the sample sizes equal if it is possible. Okay, so if you are taking sample 1, if you are taking sample 2, the size should be same. Values are different, size should be same. Okay, for example, in sample 1, if you are taking 10 points, sample 2 you are taking 10 points, so there should be 10 points each. Don't do like this. Sample 1 is having 10 values, sample 2 is having 100 values, and now you are comparing the mean of them. No, don't do that. ऐसा नहीं होता. Sample का size तो same लेना पड़ेगा. Sample size should always be same. Okay, don't take the different samples values. Okay, that means इनका अलग अलग नहीं करना. All right, fine. Values means the number of the data points. ठीक है, वो सेम रखना है. ठीक है. For two samples that test, we have to take the two samples. T test में less than 30. So just confuse नहीं करना. If someone asks you what is T test and what is Z test. Okay, you will say, listen. You will say, okay, both are the hypothesis testing techniques. In both the cases, we are going to compare the mean. Just tell them, both we are going to compare mean. Okay. In t test the sample size is less. In general, it is less than 30. In Z test, the sample size is more. Sample size is more than 30. More than 30. Okay, that's what you have to tell. More than 30 sample size. In T test, the sample, because it is less than 30, so it looks like T distribution. In Z test, because it is more than 30, it looks like normal distribution. Okay, we can have one t test, one sample t test, and two sample t test. If we consider one sample t test, that means we are having only one sample. We do find the mean of it, and we take the population mean and compare it. Here, population is considered. In two sample test, we are having two sample S1 and S2. The data points, the number of data points which are present in both the samples should have to be same. And again, we do compare the mean S1 and S2. Find the mean of S1, find the mean of S2, and compare whether it is same or not. Same or not. That's it. That's what you have studied in ANOVA also. That's some certainly you have studied in chi square also. Okay, that's what you have studied. बस कंपैरिजन करना है वैल्यूज का. Okay, you are taking the samples and comparing the values. Okay, fine. That's what you have to do. Okay, so ये आपका टेस्ट है. जितने भी हैं हाइपोथेसिस टेस्टिंग के, दीज आर सम एडिशनल पॉइंट्स विच आई वांट टू कंसिडर, which I want to tell you. Okay, apart from ANOVA, apart from chi square, at least you should have a clear mindset that what you are going to perform in the hypothesis testing. So how the thing goes. Step number one, you are available with the data. You do perform all the analysis over the data. You do perform modeling over the data. You do get the results from the data. ये सब पूरा काम हो जाएगा कंप्लीट. After that hypothesis testing is applied. After this thing, that means when you do the entire project, after that hypothesis testing is applied, the person may ask you, if you're doing some research, if you're doing some project, the person may ask you, kindly, they will question you, kindly validate your results. And it may happen that they will give you a problem statement. It may happen that they will give you a problem statement. If the t tests work well for both the samples, okay, both the sample size small and z only works for the larger samples, why wouldn't we say just to use the t test? Is there any situation for z test or better hypothesis? Not mandatory, sir. Okay, it's just an like, depending upon the sample sizes now, we have defined t test, z test. Okay, all these things. Okay, depending upon the sample size, they just took a reference value 30. Okay, and in general, it is considered that we do take a very small sample of data. Sample means small only, sir. Sample means small only. Okay, so we do follow t test, t static t test. Okay, if the sample size is more, then you can have a z test. However, both are just like, okay, depending upon the sample sizes. That's it. The only difference is related to the sample size. And 30 is certainly a reference value mentioned here. Just a reference value mentioned. Less than 30, T. More than 30, Z. That's it. Just a reference value. If you are having a less than 30 sample, you whatever you are doing, that is a T test. More than 30, whatever you are doing, Z test. That's the difference. Rest all are same. And just only the comparison is with respect to the mean. Okay, the results which you are getting, just comparing with the mean, whether it is same or not. That's it. Okay. Always we use T because of sample size. No? Sample size. We do always consider sample size less. So T is preferred. T is preferred. Okay, over Z, T is preferred. Fine. And I already taught you student T distribution. Student T distribution. And that is specifically meant for small data only. Small data. You have to consider small data, and and that is the deal. You have to prove, okay, that you have taken a small sample of data, and now you're talking about the entire population. How much confident you are. That is the deal. Okay, because the sample size increase, if the sample size increase, it will tend towards normal distribution. Okay, so t-test we are considering, we are preferring the t-test, we are working on a very small sample of data to perform a test. That is the reason. We don't take a big sample. No, small sample of data. Okay, that is preferred. Take a small sample. That is why t-test has been considered. All right. Hmm. So this is the thing. Okay. So you have been asked to validate your result. You have to define the hypothesis. Okay. Hypothesis you have to define. Okay. Null hypothesis, alternate hypothesis you have to define. And you have to apply a test over it. Over it. The question came, you mostly do T static. T static. You mostly do this thing. The reason is I do always take small sample of data. Small sample. 30 is just a reference value mentioned in my notes. Not everything is mandatory. Okay, not everything is mandatory. But 30 is just a value, reference value, margin value mentioned. If you're having less than 30 data points in a sample, 30 data points in a sample, in a sample, then apply t test, because in that particular case you are not going to have a normal distribution. Obviously you are going to have a t distribution only, because small sample पर t distribution ही होता, normal थोड़ी ना होगा. But if the sample size increase, तो ये तो नॉर्मल की तरफ चला जाएगा. इट विल टेंड्स टुवर्ड्स द नॉर्मल. बात इतनी सी है. तो टी नहीं होगा, जेड हो जाएगा. देन इट विल बी जेड, जेड टेस्ट. देन इट विल कन्वर्टेड इनटू जेड टेस्ट इफ द सैंपल साइज इंक्रीज. तो उसका नाम बदल दिया अपन ने, बिकॉज डिस्ट्रीब्यूशन जब बदला, बिकॉज द क्वेश्चन आस, सिंस वी आर टेकिंग डिफरेंट डिस्ट्रीब्यूशन, टी डिस्ट्रीब्यूशन and normal distribution, two different distributions we are taking. So in regards to that, they told, if you are having a small sample, then t test. If you are having a big sample, then z test, because it is likely towards the normal, this is likely towards the t distribution. Okay, and distribution is everything, distribution is important. Okay, fine. Data distribution is everything. So accordingly na, they have told. Okay, so we do follow t test mostly. However, z test is also been there, z statistic. Okay, fine. So this is how you do perform hypothesis testing. These are the concepts related to hypothesis testing. Okay, very much important. We'll be proving this hypothesis over some set of data. We'll do that. Okay, implementation and all these things we'll do. Okay, then the things will get more clear. However, you have seen the numerical in the previous classes, but we'll do the implementation also. Okay, fine. All right, all right. Let me stop presenting. Let me stop the recording also.